Okay, well, we'll just take it away then. Want to introduce Vitalik, who needs no introduction. His talk is about scaling Ethereum in 2020 and beyond, and I'll just let you take it from here, B. Thanks very much.
Excellent, great. Just checking, you can hear me, you can see the slides fine?
Everything's great.
Okay, great. So, hello everyone. Good to be speaking to wonderful Ethereum people again. I'm definitely sad that I can't see you in person. Hopefully we can fix that up next year in August in Bogota, as apparently got announced overnight a few hours ago. So, yay. But today I'm going to be speaking about some Ethereum scaling. So basically taking a look at where we are in terms of our ability to scale, where we are in terms of the need to scale, and just what the realistic paths are that we can take to get there, right? So major piece of good news is that rollups are here, right? I'm sure many of you have tried doing Gitcoin grants using ZK Sync as a payment option, and it actually works like surprisingly conveniently, right? And like when you go through the Gitcoin kind of checkout thing to do your quadratic funding donations, you just select checkout with ZK Sync, and you have a couple of sign-ins. And if you've never used ZK Sync before, you need to send one transaction, basically just to kind of top up your ZK Sync account as part of the process. But if you've already done that, then you don't need to send any transactions. You just sign these three cryptographically signed messages. So basically MetaMask signs some data that's not a transaction, and then that gets included as part of the ZK rollup. So the transaction fees are really low. It's like basic for like the 10 cents over here. It's somewhere between 100 and 200 bytes on chain. It costs much less than even a single transaction. Really nice and really fast. Loopring, ZK rollup based decentralized exchange. It's existed for a while. It also has a built-in payment system. So if you don't care about trading one random crypto token for some other random crypto token, you can just use Loopring to pay people. And I've actually used Loopring to receive money myself. I paid for lunch for a group of people, and one of them was kind enough to unsolicitedly pay me back for his share. I'm just directly inside Loopring, which was really cool. And the transaction fees were pretty negligible as expected. Diversify, Starkware based decentralized exchange using Starks. So this is trusted setup, free, quantum proof, and all of those things, or at least potentially quantum proof. I don't think they used the internal signature algorithm as quantum proof yet. But this has also been seeing quite a bit of usage. OMG, so who here has heard of Plasma? Who here has kind of quietly forgotten about Plasma? Well, Plasma's back from the grave, and it's going strong. If you go to omg.network, they have a wallet over here, and it's not a rollup, it's a Plasma, but it's still a scaling solution. It's still crypto economically secure and all that, and you can use it. And finally, Optimism, the optimistic rollup project, launched a testnet, and Synthetics is running a test on it, so you can go and use it. So rollups are here, but they're not completely here, right? So most activity that's being done on Ethereum is still being done on the Ethereum layer 1. These three rollups are just payments and DEX. So ZK Sync is literally just payments, but Optimism is supporting full EVM smart contract, so you can just kind of click a button and redeploy your contracts to it. And it is a testnet now, but they have plans to kind of move over to being a mainnet soon. Starkware, I should mention, they have this project called Cairo, and they've been starting to compile Solidity contracts into a Stark, which is just really amazing. So a lot of progress even on that front. Phase 0 is almost here. So ETH2, yay. The first phase of ETH2 is very close to being here. The Medasha testnet has been running for a while. And we've had Spadina as a kind of a live test of the launch process. We're going to have, forget the name of it, Zinkin as another live test of the launch next week. So clients are doing really well. A lot of efficiencies coming in, a lot of bugs getting fixed, and the bugs getting smaller and smaller each time. So phase 0 is almost here. So a lot of progress happening, right? And at the same time, there's a big need for this stuff, right? And the reason why there's a big need is because, well, demand for using Ethereum is really high. A lot of people want to use the Ethereum blockchain, and there's just not enough space in the Ethereum blockchain for everyone. So how is that getting resolved? Well, right now it's getting resolved by gas prices going really high, right? And at the start of the year, gas prices of like maybe 2 to 5 gwei were pretty common, but today, if you go to gasnow.org right now, I think, and I'm not going to check now, but last time I checked it yesterday, it was somewhere between 50 and 100, and a couple of weeks ago, it got all the way up to about 700 or so, right? So, gas fees are crazy. I tried out making a trade on the Augur prediction market a couple of days ago, and the transaction fees were to make that one trade were a total of $17.76. So, it would be nice if sending transactions was cheaper. The only way sending transactions can be cheaper is if we have more scalability. So how do we get more scalability, right? So this is kind of the path over the next 1 to 2 years that I realistically see. Basically, right now we have the Ethereum layer 1, and it has somewhere between like 15 to 45 transactions a second. So the 15 number is if just to look at current usage, the 45 number is if everyone stopped caring about smart contracts and just sent 21,000 gwei and of simple transactions. 1,000 to 4,000 TPS is if you go to rollups on top of ETH1, right? So if everyone moves on to rollups, whether it's ZK rollups or optimistic rollups, then you get up to about 1,000 to 4,000 transactions per second. Each transaction only requires somewhere between like 300 to 1,000 on-chain gas. So the 4,000 number is for either simple sends or simple trades or anything that can be fit into about 15 bytes, which is a lot of things. And the 1,000 number is if you go up to about 64 bytes, which is where you need to go to do a ZK rollup. So you can even get 1,000 TPS with privacy potentially if you do a ZK rollup. And then this is using technology that's basically either out there or almost ready today. And then this number, crazy number, 100,000 TPS for relatively simple transactions and 25,000 TPS for privacy preserving transactions. And this is rollups on top of ETH2, right? So when you have ETH2 and then we have phase 1 that adds sharding of data on top of ETH2, then rollups on top of that have a much larger amount of data to work with, something like 2 megabytes per second. And that's at the beginning. I expect it'll go up even beyond 2 megabytes per second over time. And so on top of that data, you'll be able to do a huge amount of transactions and basically just combine the scalability mechanism of sharding with the scalability mechanism of rollups. And you basically have like enough capacity on Ethereum to get pretty close to being able to run the entirety of WeChat on the thing if you really want to or something like that. So the question is, right, like what can we do to adapt to this reality? I think my first major point is that this is a reality, right? I think if we want to have an acceptable user experience for users, like there isn't really a choice per se, right? Like rollups are basically the only technology that's there ready to scale Ethereum applications from their current level of scalability to something 100 times greater without compromising on the security, right? Like, you can have your side chains with your two-way bridges, but for any of those systems, like obviously you have to trust whatever committee actually runs the sidechain. With rollups, you don't have that problem. So rollups are basically the only path that, as far as I can tell, is just there to allow for this scalability improvement that we really, really need and we really need today. And so the only question basically is like, what can we do to adapt to it, right? And the biggest part of the answer basically is that we need some kind of comprehensive ecosystem level push to improve user experience. And in user experience, I'm including security, right? It's never user experience versus security, it's user experience of security. It's so improving user experience of security for layer 2 protocols. There's a few pieces to that puzzle. So first of all, wallets. So if you go back to this ZK Sync inside of Gitcoin, like it's not the best, right? And the reason it's not the best is because the ZK Sync thing is being kind of instantiated inside of the Gitcoin webpage. And so if Gitcoin was evil, then Gitcoin could just make a fake ZK Sync sign out page and like basically ask you to sign into ZK Sync, and you would sign in and they would be able to just steal all the assets that you have inside of ZK Sync, which is not very nice. The correct approach to solve this problem is that the support for optimistic rollup and ZK rollup and Plasma needs to be pushed up to the wallet level, right? So MetaMask needs to include native support for ZK rollups, optimistic rollups, and Plasmas. Status needs to do the same thing, and IM token needs to do the same thing. Like, the wallets need to all do the same thing. And this requires quite a bit of work. I think we can mitigate the amount of work that this requires if the layer 2 providers write some kind of plugin and standardize on some kind of plugin solution. But these are discussions that need to be had. ENS is another major one. So ENS is amazing, right? Lots of us use ENS. I even used ENS to pay someone a few weeks ago. So this was. So we need ENS to work not just on layer 1, but also on layer 2 and smart contract languages. So zooming in on some of these, right, wallets, we have already talked about this. ENS, you need to be able to register, administer, transfer, and renew domains entirely inside of layer 2s, right? We're talking about an ecosystem where users are in generally going to be living inside of layer 2s, right? If we talk about using Ethereum to go up to 4,000 TPS on a layer 2s, then what that means is that average users are not even going to have a quote account on layer 1, right? Average users are just going to be living on layer 2. And so ENS name resolution needs to work even for names that are registered, transferred, renewed, administered, everything happening to them entirely inside of rollups. And I have a proposal for this. There's the link. If you don't want to manually copy the link, you have this fun little QR code thing that you can scan. I don't know. Hopefully, people are familiar with QR codes by now. Basically, it's a kind of general purpose proposal that allows resolution of ENS names and more generally static calls inside of arbitrary layer 2. So this would allow both ENS and a lot of other applications to kind of live inside different layer 2s and not even have to standardize on a single one pretty seamlessly. And smart contract languages, right? So we have kind of 3 different tiers of languages in the Ethereum ecosystem. The first tier is low-level languages. So the Ethereum L1 has the Ethereum Virtual Machine, EVM. Optimism's optimistic rollup has the OVM, which is basically a subset of the EVM that restricts operations that break out of their sandbox. Stark Wars Cairo, they have their own, arithmetic and immediate representation. And like fancy blah 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 math finite field Stark. If you want to learn more, go read the blog posts. And so we have a lot of these different compilation targets, and at the same time we also have high level languages, right? We have Solidity, we have Viper, we have Serpent, we have Mutan, we have LLL, we have Bamboo, like, and there's this big long tail of other ones that people haven't heard of. So we have a lot of high-level languages, we have a lot of low-level languages, and it would be really nice if we could have a common intermediate compilation target that's easy to compile to and that's easy to compile from. And so Yule is a thing that Solidity already compiles through, and it's one option, and maybe there's other options, right? So this is another thing that probably needs to be kind of talked about and standardized through the ecosystem. Economic benefits. So this is a interesting and fun kind of corollary of a layer 2 centric roadmap, right? So far, I've been talking about needing to make this coordinated ecosystem push for people to move to layer 2s, basically for technical reasons, right? Right now, we have 15 to 45 transactions per second. People want to do a hell of a lot more than 15 to 45 transactions per second. The technology that lets people do that with Ethereum level security guarantees is rollups. And so, we need to move people into rollups. And in order for that to happen, all of the infrastructure that currently exists to make life easier for people on layer 1 needs to also work for people who live inside of the various different layer 2s that are starting to come into existence and are going to keep coming into existence over the next year or so. But there's also this interesting kind of economic benefit, right? So Ethereum in general has a public goods funding problem, and it arguably has a problem kind of attracting kind of creative researchers and developers to kind of help with the scaling process. And there definitely is a strong team, and like Justin is great, and Danny is great, and Dan Krat is great, and Chelway is great, and a whole list of people that I'm going to offend by not mentioning their name are all great. But there's also this very large set of researchers and developers who I think, first of all, just feel more comfortable and kind of want to be kind of have the freedom to build their own island and not just be a small piece in a big ecosystem and have to debate with everyone else over every protocol change. And also from a funding point of view, like core development is currently funded just by the Ethereum Foundation. The Ethereum Foundation has a kind of one-time limited pool of funding, which is totally fine for the next few years or so, but what's the long-term sustainable solution? And layer 2 projects have much more leeway than Ethereum in both of these dimensions, right? If you create a layer 2, then you as a researcher, developer, founder have the ability to kind of build your own island, so to speak, and experiment with a lot of different options and kind of come up with your own path of various different improvements. And at the same time, layer 2 projects have the ability to monetize, right? So layer 2 projects have the ability to kind of fund themselves by making MEV auctions. For example, this is something I've talked about. There's a lot of, they can charge transaction fees for state rent, and there's a lot of things that they can do. And layer 2 projects that could either charge for these things directly, and they could potentially do the token thing and create one of these kind of decentralized community tokens that gets backed by future transaction fees collected by the system. There's a lot of things that they can do. And so basically, if the Ethereum roadmap has a kind of big space in it for layer 2 projects, then the Ethereum ecosystem and a lot of these other projects can kind of align instead of competing, right? It's not, are you part of Ethereum or do you build your own thing? It's no, you can be part of Ethereum and build your own thing. And so as a layer 2, you have a huge degree of kind of economic and technical autonomy and kind of lots of opportunity to do things. So this is the short term, right? And I think the short term is, at least my impression, is that we don't really have much choice except to do this, basically just because we need scaling and rollups are the technology that's here. And we have done our kind of due diligence, and we've done this huge exploration of the entire scaling space. We've looked at plasmas, we've looked at channels, and plasmas are going to continue to be used, and plasmas are great. And channels are going to be continuing to be used in their particular context. Some channels could even be used for things like moving between different rollups and plasmas quickly. But still, out of the kind of design space that we've explored, rollups make up this kind of really big part of it, especially for applications more complicated than payments. And even for payments, kind of layer twos of some kind are the thing that we need to be making this coordinated effort to start moving toward. But this is the long term, right? And this is the kind of more controversial part of my proposal. So first of all, ETH2 phase one, right? So not controversial yet. Controversial is next slide. Use ETH2 shard data for rollups, right? So if instead of the rollups pushing their data onto the ETH1 chain, rollups can push their data. So the 10 to 16 to 50, depending on your application, bytes of data per transaction that have to go on chain in a rollup, because that's how rollup works. So if that data goes on to ETH2 shards, and these two shards have 2 megabytes per second all collectively, then you can get up to 100K transactions, or 25 for much more complicated ones. But we need a bridge so that the ETH1 chain can verify which ETH2 block roots, and therefore which ETH2 blocks are legitimate. And then after phase one, in phase 1.5, ETH2 shard data can be proven to the ETH1 shard within one slot, because the ETH1 shard will be part of ETH2. Now, this is the challenging part, right? So I claim that we have a bit of an awkward inconsistency in the ETH2 and scaling roadmap. Here is the awkward inconsistency, right, that I think hasn't really properly been addressed yet. Today, we have no layer 2. Well, we have some use of layer 2, right? But okay, let's say we're here in the chart. 6 months ago, we were here. 6 months ago, when 2020 and the world burning and so forth had only just begun, and we were still living a relatively happy existence in the Great Stagnation. The scalability of Ethereum was about 15 to 45 TPS, because we had no layer 2 and we had no sharding. Very soon, we're going to have 1,000 to 4,000 TPS, because we have no sharding, but we do have rollups. In 1 or 2 years, we're going to go up to 25 to 100,000 TPS, because we are going to have sharding of data, right? So the shards are just going to be kind of data blobs, but for a rollup, data blobs are all you need, plus rollups. So here, no sharding, no rollup. Here, no sharding, yes rollup. Here, yes sharding, yes rollup. And then what comes after this? Well, ETH2 phase 2, right? ETH2 phase 2 basically says, well, we're going to allow shards to have not just data, but also execution. And this was always marketed as, this is the place where applications can come over and actually properly live inside of ETH2. But here's the problem. This phase offers 25,000 to 100,000 TPS, because it has sharding and rollups, so it has scalability squared. But over here, if we're going to say, well, we want applications to move to ETH2's layer 1, well, being on ETH2 layer 1 means you only have one level of scalability, right? You have sharding, but you don't have the rollup. And so the question is, well, if the ecosystem is already accustomed to rollups, and because the ecosystem has to be accustomed to rollups because they will have spent 1 to 2 years over here living in a basically rollup-centric ecosystem, then why would people even want to migrate back to the main chain when the main chain has inferior scalability, and when they're already accustomed to rollups having juicy features like, for example, sequencer pre-confirmations and sequencers being able to do crazy transaction verification, so you have full account abstraction without the complexity of account abstraction, the EIP, and all of these other goodies. Like, why would applications want to move back to the main chain? And this is the challenge, right? So, like, basically the question is like, what if the scaling roadmap is really done here at the 25,000 to 100,000 TPS step, and we shouldn't even be kind of adding more complexity to Ethereum by allowing more computation on every single shard. Now, there's actually risks to allowing computation on every shard, right? And the risk basically is that if you want to kind of fully verify correctness of a sharded blockchain, then if you want to verify data availability, it's data availability verification. If you do it with either polynomial commitments or zero knowledge proofs, is actually not that bad. The reason is that it does not have any network synchrony assumptions, right? It does not rely on fraud proofs. It's just a matter of like send a bunch of requests and wait until all those requests get answered. So no matter how slow the network is, no matter what happens to the network, you're fine. But if you want to verify computation in a scalable way and in a robust way, and so like for example, the network, like half the nodes temporarily going offline and the attacker kind of taking over a large portion of the remainder, and then being able to take over a few committees. Like if you want to verify scalable execution without hitting those kinds of issues, then you need fraud proofs. And the problem with fraud proofs is they depend on this hard latency assumption. And so if someone manages to kind of sneak past an invalid block because the network is doing really terribly for 12 minutes, then you would pretty much have to roll back the entire ETH2 chain. So I would claim that potentially leaving scalable execution up entirely to layer 2 could even kind of improve the stability of the Ethereum 2 blockchain and make it a more kind of limited and entrenched tool that does one thing and does one thing well. Now, there is an opportunity for a compromise here, right? So, and the compromise basically is, well, I talked about having just one execution shard, and the current, the status quo kind of proposal is to have kind of 64 execution shards. So like every shard is an execution shard. Well, the compromise proposal is, what if we go in the middle? What if we have like 4 execution shards or 8 execution shards? And this would allow somewhat more base layer applications to exist if people really want them to. It would allow somewhat more room for error if things inside of a particular rollup screw up and people have to use the base chain to migrate to another one. It would allow, it would really relieve pressure on a lot of those things. But if there's only 4 to 8 execution shards, then in extreme circumstances, it's still within the power of a lot of individual users running nodes to personally verify all of the computation that's happening in the network. Right? Whereas if there was 64 execution shards, then personally verifying all the computation would be impossible. So that's the kind of a possible compromise approach. And so challenges, right? So there's a lot of challenges that are, I think, inevitable in the ETH2 migration. And as I mentioned in the migration to rollups, there's a lot of challenges that are pretty inevitable as well. But probably the biggest one is a user experience, right? Basically making sure users only do secure things by default and don't accidentally do insecure things. So one example of an insecure thing would be as if every application required you to sign into ZK Sync inside of that application, and then users ended up by kind of giving away their ZK Sync secrets and the application stole all their money. That would be really bad, right? So we want secure things to happen by default, and so we want MetaMask or Status or like IAM token or these wallets to try to support layer 2s directly instead of having a kind of less secure application interfaces for them. Ecosystem coordination. And that includes the wallet stuff, that includes making ENS work on layer 2. It includes kind of high-level language things. It includes also having efficient infrastructure for jumping between different rollups. So kind of cross rollup exchange is going to be a really important topic. So there's a lot of these challenges that do kind of have to be solved regardless. One interesting thing about kind of cross rollup exchange actually is that I think a lot of the challenges are very similar to the challenges around cross shard exchange. Basically, rollups and shards are both kind of what I call synchronous domains. They're both these areas where you can have synchronous communication between objects within one of them, but you can't really have synchronous communication between objects that are in different rollups or in different shards. And so the challenge of making a DEX between them is basically very, very similar, regardless of whether they're rollups or whether they're shards, which I think is interesting, right? It basically means that we don't even need to have all that much certainty of kind of which scaling path Ethereum is going to take in order for work on cross-domain exchange to actually start. And so cross-domain exchange is something that people should actively start looking into. You know, go if you want to build some hackathon project at some point, then make a DEX that works between say a ZK sync and the optimism testnet, for example, like just try, or even between loopring and ZK sync, or between loopring and the optimism testnet, or diversify, or whichever one of these systems, right? Just see if you can spec it out, see if you can make that work, because this is a kind of category of thing that we're going to end up needing. So that's the presentation, right? And I know there's a lot of ideas in there. It's ideas that I think we're all kind of familiar with. I mean, independently, right? We're all familiar with ETH, hopefully, ETH2 as a concept, at least the basics of it. And then the fact that there exist these layer 2 protocols as a concept, but actually you're kind of concretely thinking about, well, what would a world where we migrate to layer 2s, and then what would a world where we migrate to layer 2s on top of ETH2, and how will ETH2 and layer 2s interact and all that. These things are fairly new, and I think it's time that we do start to kind of much more seriously and proactively thinking about how we kind of push the ecosystem to actually be able to take advantage of this scalability.
Great, thanks, Vitalik. Thank you for the presentation. We do have some questions that have been submitted, so as long as we got time for it, we'll chew through some of them. All right, so first question. Layer 2 is always about to solve all of blockchain's problems. It's something that we've been writing and talking about for years, but at least for now has failed to really materialize, and there have been notable disappointments in the layer 2 space. How confident are you that rollups are for real, and what makes this time different?
So I think I talked about this a bit in one of my blog posts about a year ago. This was, I think, the one that talks about base layers and functionality escape velocity. And the argument that I made was basically that rollups are a somewhat different class of scaling solution than channels and plasma, right? And channels and plasma were kind of the two major families that, like the Bitcoin and Ethereum ecosystems. In the Bitcoin ecosystem case, just channels that we've tried so far. And the difference is basically that, like, when you scale, you have, there's two things that you're scaling, right? You have to scale computation and you have to scale data availability. And my argument was that channels and plasma both don't solve data availability. They use very application specific tricks to try to get around the problem of not having data availability. Right. So if you search up on my blog post, the vitalik.ca base layers functionality escape velocity, I make this argument in a lot more detail there. And so within the case of rollups, on the other hand, the way rollups work is that they're a kind of more compromised layer 2, right? They say that instead of doing everything off chain for every transaction, we're not going to do the computation on chain, but we are going to publish about 10, 16, 50 bytes of data that go on chain. And so this is why the scalability of a rollup is limited. But what this gives you is it gives you the ability to basically run arbitrary state machines inside of a rollup, right? And this is the thing that we initially thought we'd be able to do, then eventually realized we can't do in Plasma, is basically run arbitrary state machines inside of them. But for rollups, we already know how to do it, right? And once you can do an arbitrary state machine, then it's kind of like Turing completeness. That's proof that you can do basically anything. So we do have a kind of mathematical and technical sort of proof that rollups are capable of doing the things that we're claiming they're capable of doing. And then in terms of just in practice, right? Like rollups are just so far along. There's already like 3 decentralized exchanges running on them. There's you can use it to like do like checkouts of your Gitcoin donations, and then there's a Synthetics is participating in a testnet of a rollup that can support the EVM. So like it's basically the problems that we never even got close to solving in channel and plasma land, I think in rollup land we actually have managed to solve, is the crux of it.
Got it. Okay. So one of the virtues of the Ethereum ecosystem that exists now is, we have this kind of interoperable, composable layer 1, which means that everything gets to talk to everything else. Can that vision still exist in a world of many rollups? Or do you expect there to be a winner take all here where, one or very few rollups end up having the most amount of economic activity on them?
Sorry, I didn't hear the last sentence too well. What was that again?
Oh, do you expect to be a world of many rollups, or do you expect a winner take all dynamic?
Good question. I definitely expect to see a couple of rollups end up dominating. I do think that rollups have both network effects and anti-network effects. The main anti-network effect that a rollup has basically is that the more transactions per second happening inside of a single rollup, the harder it becomes to run a full node of that rollup. And so that basically kind of degrades its usability to some extent. So that's one pressure to have multiple of them. And then the other pressure is that there's just different families of technology that are being explored, right? You have the optimistic EVM family, then you have the zero knowledge proof using elliptic curves family, then you have the zero knowledge proof using Stark's family. And so I definitely expect kind of all of these technical families and some different internal features to get tested in the short and medium term. In the long term, it's possible that one of them will win. I don't know yet.
And do you think, are there fundamental problems that happen? Like if there is a winner take all dynamic, like what are the downsides of that happening?
Right. I guess the main downside would be that if the winner that takes all ends up being a project that just starts being really extractive in nasty ways, and it has like fairly centralized control by a small group of stakeholders, and those stakeholders try to basically maximize their benefit instead of doing a good thing for the ecosystem. I think if that happens, the Ethereum ecosystem's response may end up being to kind of quote nationalize it. So what I mean by that is basically just like take that code, the code of that particular rollup, and just like enshrine it into the main chain and make that be phase 2 of ETH2 scaling. And so when that happens, basically people that are like, it will just be the default behavior of Ethereum users to be living inside of that rollup, but then that rollup will just be, using ETH as its base asset, managing that rollup would be part of managing the Ethereum protocol and so forth. So like if you are a winner that takes all and you're too mean, like there's always the possibility that that'll end up happening. And so your kind of position at the center of things will end up just being sort of removed overnight as a result.
Okay. Another question that was submitted. So the assumption of this question is that when you've been talking so far about transactions happening on rollups, those are still public transactions that anyone that's kind of watching the rollup chain can see. What would like a private rollup world look like, or how would like having private transactions in the rollups maybe impact the scalability properties that you've talked about so far?
Mm-hmm. Right. So this is where we get into the family of ZK rollups. The first ZK stands for zero knowledge, and the second ZK stands for, as I now claim, zipped by cryptography. So it has ZK for both the privacy and the scalability. And basically, So this is a family that's already being explored. So the Aztec protocol is working on a ZK rollup. I believe Matter Labs might be. I'm not. I forget the details, and I'm sure they can angrily correct me on Twitter if they want to, which would be great. The basically the idea would be that, like, if you imagine it with like something like Tornado Cash, then imagine you extend Tornado Cash so that it doesn't just do moving coins around, it also does basically supports an internal smart contract language, and then you imagine that living inside of a rollup. Then you do get some pretty powerful privacy and scalability at the same time. I think the main challenge, though, is that there's inherent trade-offs between like privacy and composability, and between privacy and just having applications that everyone can use. And the trade-off is basically that if you want to have private smart contracts, then like for that to work, you need to have this kind of encrypted state object where only some people have the key, right? And the idea is that if you have the key, then you can make transactions that involve that state object. But if you have the key, then you can also see what's going on. And so like basically there's this kind of inherent trade-off with zero knowledge proofs where, you know, you can like basically either you can see what's going on or with a particular object, or you can't use it, and that's totally fine with coins, right? Because if the coins are yours, you can see them and you can use them. If they're not yours, you can't see them and you can't use them, which is why, you know, Zcash and Tornado Cash and so forth work fine. But with smart contracts, you get into multi-user objects, and so this sort of stuff gets more difficult, right? So going from perfect privacy of kind of simple payments transactions to perfect privacy of more complex things. And I think perfect privacy of more complex things is not possible, but kind of pushing the frontier up, I think, is something that's going to happen over time. And yeah, and wonderful people like the Aztec team are working on it.
Okay, so changing topics a little bit. Another question that was submitted. So in this vision, you know, which is one possible vision you described in this post, when would you expect the base layer of Ethereum to stabilize? Is there a period where becomes stabilized and very few changes are made, or would you expect iterative improvements in perpetuity?
I mean, in my proposed roadmap here, I expect the basic structure of the roadmap of ETH2 to basically stabilize potentially forever in phase 1.5. So like in the Magician's post, that's why I say phase 1.5 and done. But there would continue to be kind of iterative technical improvements, but this would be things like, for example, just adding more zero knowledge proofs in a few places to improve security, improving efficiency, changing the consensus from FFG to CBC, eventually migrating to post-quantum. So kind of improvements that are not sort of economically substantive, or that are not kind of substantive in terms of changing basic security properties. And then like I definitely expect some degree of ongoing technical change to keep happening for a very long time, but it would be a low level, like definitely much closer to just being maintenance mode.
Okay. So the last question, which I just got for you, is what do you want to see hackers build at ETH Online over the next 3 weeks? If you maybe you've got something already in mind, maybe you have long-standing things that no one's built yet, but if you could name a couple things, what would those be for the hackers who are watching and looking for inspiration?
Mm-hmm. I mean, one option is definitely just the things that I talked about. So kind of readying the Ethereum ecosystem for layer 2s. So this could include like, the ideal awesome thing would be like make a MetaMask fork that just supports, Loopring and ZD-Sync and Optimism, which would just be awesome if someone does it. Another example would be a decentralized exchange, whether it uses like channels or whatever other technology going between multiple rollups. An ENS resolver that works inside of layer 2s. Other interesting things would be like layer 2s offer the ability to do things that you can't as easily do today. One example of this is smart contract wallets, right? Like I've always been like this big advocate of smart contract wallets and multi-sig and social recovery and all of these things. But this stuff is still underrated, by the way. Like even a few weeks ago, I just had a friend kind of come close to losing $200,000 just from kind of misusing their or misplacing their wallet seed. It was eventually I had to go digging quite a bit and figure out that it was like basically it was the BIP32 derivation path was wrong or something like this, but like it was a big scare for a while. And I think people don't talk about this because like there's this mentality that like, oh, if you admit to losing $200,000 because you lose your key, then you're stupid. And so, you know, nobody wants to admit it, but it's a serious problem nobody talks about, right? But basically, I think if we want to scale Ethereum to 5 billion people, you can't have this design where you have one private key, and if your private key gets stolen, you lose your money, and if your private key gets lost, you lose your money. So, you know, you want to have multi-sigs, you want to have like these cancelable transaction vaults, you want to have like social recovery and all of these things. And ideally try to solve it with a minimum amount of centralization as things like social recovery do. But these things are all fairly hard to achieve in the current context because, you know, unfortunately, these one blockchain isn't really that well designed for verification schemes other than single elliptic curve signature verification. But inside of like the Optimism rollup, for example, you totally can do it. And you know, sequencers can just support account abstraction manually. So that's another example of like the sort of thing that you could try to start doing on layer 2 is that you can't easily do on layer 1, and hopefully, and if you use the layer 2 switch as an opportunity to simultaneously encourage people to move to better things. So yeah, and I guess another possibility would just be making a kind of migrating applications to layer 2. So for example, like something like imagine making a bot that where if a market gets opened on Augur, then you know you would just immediately you know go to Foundry, create like a huge amount of yes tokens and no tokens, and then push those tokens into the layer 2s, and then just like open up a market for both of those tokens inside of the layer 2, so people can go do their prediction market trading inside of the layer 2. Right, so there's a lot of simple application specific things you can do like that. And then, you know, I'll be able to do my prediction trading with paying less than $17 of transaction fees. So a lot of options.
Awesome. Thanks, Vitalik. Well, I hope that people are listening. I hope that someone works on those problems. Okay, well, I think that is the end of the day's stream. Thank you so much, Vitalik, for coming on with us and talking about this. We look forward to having you back on the final day of ETH Online on the 30th. And until then, talk later.
Sounds good. Enjoy
Thanks,
your
Steve.
month.